EIE Instruments Private Limited presents Step 2. Finding out calorific value of unknown sample. Here, we will show you the test with one example. The sample is pressed in the pellet press and approximately a pellet of 1 gram is prepared and accurately weighed in the analytical balance nearest to 0.1 milligram. Also weigh the crucible to the nearest 0.1 milligram and place the prepared pellet into the crucible. The ignition wire of 6 cm length or 5 milligram weight is connected at both the pole of the bomb, and cotton thread of 60 milligrams or 10 centimeters length is looped surrounding the pellet, which is connected to ignition wire. Put 1 milliliter of distilled water in the bomb with the help of pipette. Now, place the crucible with sample, ignition wire and cotton in the bomb and close the lid of the bomb gently. Thereafter, charge the bomb with the oxygen to a pressure of 26 kilograms per centimeter square. Simultaneously, close the regulator valve as soon as required pressure is attained. Now, place the bomb in the calorimeter vessel and transfer the calorimeter vessel in the water jacket of the bomb calorimeter. Put sufficient water in the calorimeter vessel to cover the flat upper surface of the bomb. Approximately 2000 milliliters of water is required to cover the top of the bomb. Maintain this quantity of water in every test. The temperature of the water shall be about 2.5 degrees lower than that of the water jacket. Now, connect the bomb and firing unit with the help of paired wire. Close the cover of the jacket and place the stirrer motor on its place. Also, insert the temperature sensor of the digital temperature indicator. Now, on the panel of the firing unit and start the stirrer. Ensure the closed circuit of the ignition wire by observing LED. Read the temperature on the display and allow to stabilize the temperature for not less than 10 minutes. As soon as temperature is stabilized and remains steady, press the set key and read the lower display 0.00 degrees Celsius. Note down the initial temperature to 0.00 degrees Celsius. Press the push button switch for few seconds for fire and observe the increment in temperature value in lower display. Observe the rise of the temperature to the maximum value. Allow to stabilize, and as soon as the temperature starts to decrease, note down the maximum rise of the temperature. As for example, rise of temperature is 2.48 degrees Celsius. Remove the stirrer motor and sensor from the top of the vessel and also remove the lid. Remove the bomb from the calorimeter vessel. Release the pressure by pressing the release valve and dismantle the bomb. Now, calculate the nitric acid correction as follows. First of all, prepare the solution of 0.1 normal sodium carbonate by dissolving 5.2996 grams sodium carbonate in 1 liter distilled water. Wash the bomb approximately with 100 milliliter distilled water at all inner side and inner top, including crucible and poles of the bomb. Boil the water and allow it to cool to room temperature. Add 2 to 3 drops of methyl red or methyl orange indicator in water and titrate the same with 0.1 normal sodium carbonate solution. Measure the volume of sodium carbonate solution utilized for titration, say 2.8 milliliters. Now, Calculation to find out the calorific value of sample is explained with example. Weight of crucible plus thread is equal to 5.2348 grams. Weight of crucible plus thread plus sample is equal to 6.2348 grams. Weight of sample is equal to 1 gram. Rise of temperature is equal to 2.69 degrees Celsius. Effective heat capacity is equal to 3063.24 as already derived. Now, volume of 0.1 normal sodium carbonate required for titration is equal to 2.8 milliliters. Subtract nitric acid correction B is equal to 1.43 calories per milliliter multiplied by 2.8 milliliter is equal to 4.004 calories. Now, W is equal to H multiplied by M plus CVT plus CVW plus E1 upon T, where W is equal to effective mean heat capacity, H is equal to calorific value of sample, M is equal to mass of the sample, E1 is equal to correction for formation of nitric acid in calories, CVT equals calorific value of thread, CVW equals calorific value of ignition wire, and T is equal to rise in temperature. So, H is equal to W multiplied by T upon M minus CVT plus CVW plus E1, where W is equal to effective mean heat capacity, which is equal to 3063.24. T is equal to rise of temperature, which is equal to 2.69 degrees Celsius. M is equal to mass of sample, which is equal to 1 gram. CVT is equal to CV of thread is equal to 21 calories. CVW is equal to CV of nichrome wire, which is equal to 20 calorie. E1 is equal to nitric acid correction, which is equal to 4.004 calories. By placing above value in equation, it will be 3063.24, which is the effective mean heat capacity, multiplied by 2.69, the rise of temperature, minus 21 CVT plus 20 CVW plus 4.004 E1 upon 1, that is the mass of sample. So calorific value of sample is equal to 8195.11 calorie per gram. Precautions. 1. Do not weigh sample more than 1.100 grams. 2. In the rising mode, when adjusting 0.00, if the last digit on the display fluctuates to plus or minus 0.01, disregard the fluctuation and press fire. 3. Charge bomb up to 26 kilograms per centimeter square pressure only. 4. Use only distilled water in the calorimeter vessel. For immediate use after testing the sample, replace the water in the vessel. The same distilled water can be used after a period of 45 minutes. 5. Stop the experiment if any evidence of leakage is observed when the bomb is submerged in water. 6. Do not keep the sensor in water when not in use. 7. Use of voltage stabilizer is recommended for better stability of temperature. 8. If the propeller of stirrer touches the bomb, set the assembly in right position. 9. When needed, replace the valve pin with the help of valve key provided. 10. Volatile liquid such as petrol and diesel can be weighed and handled in gelatin capsules. The calorific value of gelatin capsule can be determined by igniting capsule with known value of benzoic acid. 11. Heavy oils and other non-volatile liquid at room temperature can be weighed directly in the crucible. The thread is dipped in the sample. 12. High energy fuels having more than 10,000 calorific values are suggested for burning about small amount of sample. It is advisable to use only 1/10 or 1/5 of the usual amount of sample. EIE also manufactures bomb calorimeter with automatic calculation with PC interface and software. EIE also manufactures fully automatic bomb calorimeter.
Thank you. Wishing you an accurate testing. Please visit us at www.eieinstruments.com.